Today, we're diving into the really critical world of operational technology, or OT, cybersecurity. Now, this isn't just about protecting spreadsheets and emails. We're talking about defending the physical world, where a simple cyber attack can cause real, tangible, and sometimes catastrophic destruction. And yeah, this is what I mean. Take a look at this. This isn't CGI from a movie. It's a real-world example of what happens when digital threats violently cross over into our physical space. In the world of OT, a few lines of malicious code can literally create a tower of smoke. So the big question is, how do we stop this from happening? To really get a handle on the danger, we have to start with the battleground itself. You see, we're dealing with two fundamentally different technology worlds here, and they each have their own mission, their own rules, and their own priorities. And this right here really highlights the huge shift in thinking. In the regular information technology, or IT world, everything is about protecting data, keeping it secret, accurate, and accessible. But in the operational technology, or OT world, the number one priority, above all else, is physical safety. It's about making sure that massive, powerful machinery works reliably and, doesn't hurt people. Sure, availability is important to both, but an OT outage can shut down an entire city's power grid or bring a factory floor to a grinding halt. The financial stakes are already massive. Almost $5 million for an average data breach. But for an industrial operation, that number just explodes. You're not just worried about recovering data, you're looking at a complete shutdown of production that can bleed millions of dollars a day. So how do the bad guys even get in? Well, a lot of the time, it's through surprisingly simple ways. Remember the Colonial Pipeline attack that crippled fuel distribution in the US? That whole thing started with just one single compromised VPN password. Other common ways in are things like phishing emails, old unpatched software, or even just malware on a regular old USB stick. And the attackers themselves? They're just as varied. The threat can come from anywhere. It could be a disgruntled employee on the inside, or it could be a sophisticated, government-backed group trying to take out a rival nation's critical infrastructure. Okay, so you're facing all these different threats from all these different angles. How in the world do you even begin to defend these incredibly complex environments? Well, you start with a blueprint. So let's talk about the International Standard for Industrial Defense, IEC 62443. And believe me, the need for a standardized defense has never been more urgent. I mean, just look at this jump. We went from about half of industrial organizations experiencing an OT intrusion to nearly 3/4 in just 1 year. This isn't some theoretical problem. It's happening right now, and it's getting worse fast. So, this is where IEC 62443 comes in. It provides a clear, structured framework. Honestly, the best way to think about it is like a detailed architectural blueprint for building a fortress around your industrial networks. It tells you where to build the walls, how to guard the gates, and how to structure all of your defenses. Now, what's really crucial to understand is that this isn't some rigid, one-size-fits-all checklist that you just have to follow. It's what we call a life cycle approach. The standard actually adapts to your company's specific risks and how mature your security program is, whether you're just getting started or you already have an advanced setup. All right, let's start digging into the fortress design itself. The foundational strategy, the very first line of defense, is all about creating digital walls and moats. And we do this through a principle called network segmentation. The idea here is really simple, but it is so powerful. You take your big, flat network and you break it up into smaller, isolated zones. That way, if an attacker manages to breach one zone, they're trapped there. They can't just move sideways across your entire operation. It's kind of like the watertight bulkheads on a ship. A hole in one compartment doesn't sink the whole vessel. Here's a basic picture of that segmentation in action. Over on one side, you've got the enterprise network. That's the corporate IT world with emails and servers. Then on the other side, you have the industrial network with the special computers, the PLCs, that are the brains directly controlling all the physical machinery. They are kept completely separate, with a heavily guarded buffer zone called a DMZ sitting right in the middle to inspect and control absolutely everything that tries to pass between them. And that same exact principle can be scaled up to a much larger, more realistic level. This layered design creates lots of different control zones for different sites and different functions, from the enterprise systems way up at the top all the way down to the physical equipment at the bottom.
Each colored zone is segmented, so a breach in a less critical area, like the corporate network, is contained and can't reach the really sensitive systems that actually run the machinery.
Of course, these isolated zones still need to talk to each other sometimes. That's where things called conduits come in. A conduit is basically a secure, controlled bridge. It's the only approved path for data to flow between zones, and you better believe it is heavily guarded and monitored. So we've designed our fortress with all these zones and conduits, but that leads to the next really critical question. Just how strong are the walls we've built? We need a way to actually measure our defenses. And this is the core idea, right? It's not enough to just build walls. You absolutely have to know how strong they are. Not every part of your operation faces the same level of risk, so it makes sense that not every wall needs to be equally thick. You have to match the strength of your defense to the threat it's designed to stop. The IEC 6443 standard gives us a scale for this. It's called security levels, or SLs, and they range from 1 to 4. SL1 is your basic protection, against a casual violation by an individual. But by the time you get all the way up to SL4, you are building defenses that are strong enough to withstand a sustained, sophisticated attack from a very well-funded nation-state. Okay, so implementing this fortress design is one thing, but the real world, well, it's messy, and the battlefield is constantly changing. So let's talk about the real-world challenges people are facing and the modern arsenal of tools being used to fight back. I mean, think about this for a second. This question really gets to the heart of the problem. How do you protect systems that were built decades ago? Systems that were never, ever designed to be connected to the internet in the first place? These are the hurdles that people deal with every single day. You can't just take a power plant offline for a week to install software updates. There's a huge skills gap between the IT security pros and the OT engineers on the ground. And on top of all that, the constant demand for remote access and smart devices just keeps making the potential attack surface bigger and bigger. So a key part of the new arsenal is intelligence. AI-powered tools are an absolute game changer here. They can monitor massive amounts of network traffic and learn the unique digital heartbeat of an industrial process. By figuring out what's normal, they can spot the tiny, subtle changes that signal an attack is underway, often long before a human analyst ever could. It's all about finding the threat before it can strike. Now, this is one of the most fascinating tools in the arsenal, the data diode. It's a physical, hardware device that acts like a one-way valve for information. Data can flow out of a secure network, but because it's enforced by the laws of physics, it is literally impossible for anything to flow back in. It is the ultimate guarantee that a network segment is truly isolated. So all of this really leads us to one final critical question. The push for more efficiency, for more connectivity, is relentless. We're connecting everything, from our power grids to our water treatment plants. The challenge is making sure that our digital fortresses are being built just as fast. So, is our security actually keeping pace with our innovation?